Hello friends, in today's question, four solid spheres each of diameter 5 cm and mass 0.5 kg are placed with the centers at the corners of a square of side 4 cm. The moment of inertia of the system about the diagonal of the square is n into 10 to the power minus 4 kg meter square, then the value of n is. So I have given that there is a square, so let us suppose this is a square, and we have four solid spheres of diameter 5 cm placed at their centers in the corner. So centers of the spheres are at the corner of, this is first, second, third and fourth. So let us call this as A, this will be our B, C and D, and we are supposed to find out the moment of inertia about diagonal of the square. So let us draw a diagonal of the square. So this is one of the diagonal of the square, and we are supposed to find out the moment of inertia about this diagonal, and let us call this axis as y prime. So first of all, let us say that the sphere is having a mass of m and radius is capital R. Okay. So we say sphere mass of sphere is m and radius of sphere is capital R. So let us find out what will be the moment of inertia about an axis in this direction for A, and let us suppose this axis is called as OO prime, and another axis which is passing through the center of sphere C, and let us call that as Z and Z prime. So we can say the moment of inertia of sphere A about axis O prime will be given as 2 by 5 and mr square. So let us suppose we can write this as moment of inertia of A about axis OO prime is equal to 2 by 5 mr square. Similarly, we can say moment of inertia about of C, sphere C about the axis ZZ prime. Okay. You can say similarly moment of inertia of sphere C about axis Z prime. So we can write with this will be also equal to 2 by 5 mr square. So we can write this as moment of inertia of C with respect to axis ZZ prime is equal to 2 by 5 and mr square. Okay. Now we are going to find out moment of inertia of sphere A with respect to moment of with axis y prime. Okay. So for this we are going to use theorem of parallel axis. So you can say using theorem of parallel axis, moment of inertia of sphere A about y prime, and we can say this will be equal to moment of inertia of A with respect to OO prime axis, and now with y prime will be equal to moment of inertia of A with respect to OO prime axis plus mass and perpendicular distance between the two axes. So this will be the perpendicular distance between the two axes, which will be D, and D will be equal to 4 divided by square root of 2. So further substituting value of IAOO prime, this comes equal to as 2 by 5 mr square plus, sorry, this is md square and md square. Substituting the value, we get 2 by 5. Mass is given as 0.5 kg, so this is 0.5, and diameter is 5 centimeter. Okay, so we can find out its radius, and it is coming as square root of 5 divided by 2. I think there is some mistake if I'm not wrong. I think diameter, so this will be square root of 5 divided by 2, and it is centimeter 10 raised to power minus 2 whole square, and this will be plus, and mass is our 0.5 multiplied by D. D is 4 square root of 2 and whole square. So we can solve it further. This will be coming as moment of inertia of A with respect to YY prime axis will be coming as 4.25 into 10 raised to power minus 4. Similarly, we can find out for our, you can say, D also. Let me, you can say moment of inertia of sphere D, moment of inertia of sphere D with respect to axis y prime. So this D sphere is already lying on the y prime axis, so we can say moment of inertia of D with respect to axis y prime is equal to 2 by 5 and mr square. So this will be 2 by 5. Mass is given as 0.5. Radius is square root of 5 divided by 2 multiplied by 10 raised to power minus 2 whole square. So we get I d y prime is equal to 0.25 into 10 raised to power minus 4. So we found out the moment of inertia of A and D. Now the moment of inertia of the system, you can say moment of inertia of the system with respect to axis y prime. We can write this formula as I system with respect to y prime is equal to moment of inertia of A O prime with respect to axis y prime plus moment of inertia of C with respect to O prime and y prime plus moment of inertia of D y prime plus moment of inertia of B y prime. Now the moment of the perpendicular distance between A and axis y prime and the sphere with the axis y prime is, they are basically symmetrical. So whatever moment of inertia of A is there with respect to y prime, the same moment of inertia will be of C also. So therefore we can resolve this question as moment of inertia of the system with respect to y prime is equal to twice moment of inertia of A O prime y prime plus, similarly D and B are also symmetrical with each other, so their moment of inertia will be same. So this can be written as twice moment of inertia of D with respect to y prime axis. Now it is simple substituting. This will be twice of 2 can be taken as common, so this will be 4.25 into 10 to the power minus 4 plus 0.25 into 10 to the power minus 4. So this will be coming as one second, this is 4.25 and yeah, so this will be 2 into 4.5 into 10 to the power minus 4. So this will be 9 into 10 to the power minus 4, and it is given that the system moment of inertia with respect to the diagonal axis, that is y prime, is n into 10 to the power minus 4. So making comparison, we can say 9 into 10 to the power minus 4 is equal to n into 10 to the power minus 4. So from here we get that value of n is equal to 9. Okay, so this is the value of n. This is value of n. So this completes the question. Thank you.